Hey everyone, I hope you can hear me well. Please let me know if there are any problems. Let me test it real quick. Hey everyone. Okay, seems to be working fine. So we're going to be taking a look at two files here. One is multifile, which does, the first file is multifile.py, which does routing over vector stores, indexes. Maybe I'll show you from Langchain documentation real quick. See, router chains is selecting from multiple prompts with, well, this is from multiple prompts, but you can actually do, where was it? Maybe here. This is, so you can actually select from multiple prompts. Oh, this is, okay. I don't know why it says multiple prompts, but so you can actually load multiple documents and select from them. It automatically selects from them, or you can actually have another implementation which does, let me put this back, selecting from prompts. So we're going to take a look at both, but let's start with the multi-file because I think that's more exciting, probably more useful. What it does is you can have as many files as you like in the docs folder. It works from the folder. I'm working on the Streamlit version, but this one is going to work on the terminal. The download is available also at Patreon. Link is in the description, such as so. So you have some files here, right? I have an Isaac Newton file, which is some, I just copied some information from Wikipedia, René Descartes, Richard Feynman. I also have a PDF. I set it up so that it works with both text files and PDFs. Let's just demo it real quick and then see what it does. When you run this, we're gonna get we are already loading because I already embedded these documents, and then we're just gonna get a input for question asking, hopefully. Just 1 second. So the way this works is it loads the documents from the docs, right? There's one PDF, attention is all you need, Isaac Newton, René Descartes, Richard Feynman. And then when we ask a question, this line, multi-retrieval QA chain, actually it's supposed to decide. Oh, yeah, my bad. I have to comment this out. Sorry about that. I was experimenting with something. That's for Streamlit. I'll explain why that was happening. Sorry about that. Here. So see, it loads the documents. Attention is all you need. Isaac Newton, René Descartes, Richard Feynman. And what would you like to know? For example, we can say, what was Feynman known for? And when we do that, it enters that chain, which is the multi-retrieval QA chain. And now it's going to decide to pick which one of these indexes to use, hopefully Richard Feynman. And see, it did choose Richard Feynman index. So I'm trying to come up with the right words to explain this. So we are embedding multiple indexes, and then from the question, this multi-retrieval QA chain decides which index to use. In this case, decided on Richard Feynman. See, this is a chroma index. And then it retrieves the documents from that index and then answers the question. Feynman was known for his work in theoretical physics, quantum electrodynamics, all of that. So we can ask, when was Newton born? Again, we are entering a chain. And then this time, hopefully it's going to choose Isaac Newton, that text. It did. See, you can see it right here. Apparently Newton was born 25 December 1642. We also have a PDF, attention is all you need, and we can ask what is attention in AI. And then we'll talk about how all this is possible. Well, I mean, Langchain automatically enables it to be possible, but you also have to, you know, for convenience purposes. See, the big attention is all you need. I added that AI paper. We're going to talk about that as well. Attention is in AI is a mechanism used in sequence transduction models. So 3 times we asked, it was able to determine, okay, first we're going to look at the Richard Feynman index, Isaac Newton, and then attention is all you need, right? So what we're doing here is, okay, we're loading from the docs. Let me make this clear. Like, I'm going to delete all these indexes so we can remake them. So all we have is a docs folder, code files.zip. That's just what I uploaded to Patreon. We have this multi-file. That's all we're doing. Requirements are these, obviously. So for this to work, you need the retrievers, which are the indexes which we are creating. Retriever descriptions, which gives the description like this is useful for retrieving information, for example, about Richard Feynman, stuff like that. Actually, let's take a look at this again. If you look at Langchain documentation, see, retriever infos are, so you load the documents first. In the documentation, it uses files. So I convert it into ChromaDB. I prefer ChromaDB. I'm not sure why they still use files here and there, but so you load a document, State of the Union, program, and say it doesn't matter what you load. Then you have to give it a name, right? You have to give it a description, good for answering questions about whatever the document is. We're doing this dynamically in the code. And name the retriever, whatever the retriever is. So we're doing that. We're setting the lists for each one of them to empty, right? We're doing a recursive character splitter. You know, parameters are whatever you like. Then we check. We go through the docs directory. Okay. If so, we do a check if if we have already indexed the document, we don't want to index it, so we do check if this exists. The -4 is because the file names are going to be just the file names. We're removing the .text or .pdf out of it. That's the -4. Like, you know, we want to take that away up to -4. That is. Then we load it. If it exists, load it. Otherwise, check if it's a text file, then load it. Check for Unicode errors. So, you know, sometimes you run into those. Then split it. If it's a PDF, then use PyPDF loader and then load and split. This does it page by page. Then Dane, or JW, if you load it into VectorDB, why is it in your project files? What do you mean? Well, because it has to be, the original document has to be here so we can convert it into a VectorDB. I just deleted the vector databases because we're going to create them again. We have to create it from something, right? So this is the document and we're going to turn it into a vector database. Anyway, so for PDFs, this loader.load split with PyPDF splits it page by page. As far as text documents, we are using the recursive character splitter with chunk size of 500. This is characters, 500 characters, letter by letter, that is. Yep, and then if doc is not none, because we're setting the doc to be none in the beginning, somewhere here, yeah. But once we have the docs, right? Because we are, whether it's a text file or not, we're setting the docs, split it. Then we are creating a retriever with Chroma from documents being the doc, embeddings being OpenAI embeddings, persist directory, file name. So we are doing this dynamically. So doesn't matter what file you have in docs, this will work as long as it's a text file or a PDF file. Then we persist it. This is the syntax to do it, and then retriever is the retriever as retriever. This is just Langchain syntax. And then we append it to the retrievers, and we append the retriever names to the file names, which we set right here, right? We do need the retriever, we do need the description, we do need the names. Here it's going to become more clear because then we say retriever underscore description be appended. Good for answering questions about, we dynamically pick the file name. So you do have to pay attention to the file name because this description is going to lead Langchain to whether if it wants to choose that index. I'm just using file name. That's why I put this comment here. Pay attention to the names of the files as they will be in the description. So this is going to be important. See, this text, good for answering questions about, for example, Isaac Newton, René Descartes, Richard Feynman. But when I put in, so I originally started with these 3 text files, which are just Wikipedia articles. But then when I tried to add a PDF file, which is the attention is all you need paper, and when I asked the question, it wasn't really answering very well because it just didn't understand what it, because the only thing it has to go by is good for answering questions about, attention is all you need. Like it's not, I mean, it can fail at that point, right? So that's why I added this. I renamed the file to AI paper so that it'll know, like if it's something related to AI, well, don't go to Isaac Newton, like don't go to René Descartes, go to this. So rather than being descriptive in the code, I'm saying be descriptive in the file name, because then you'll have such a easier time because this is creating the description dynamically. So if you have a file, make it more descriptive, just rename the file so that this will work because it's dynamic. So then you can have 30 documents, like, you don't have to, you just have to rename them. Maybe there's a better way, but this is the way I did it. After that, you just initialize it. Retriever names, retriever descriptions, retriever verbose true, so we can see these things like the entering the agent, the retriever chain, whatever. You can set this to false if you don't want to see any of that. Then to interact with it continuously, I just set a while loop and just print it. That's it. But whatever your question is, and we are taking user input here. So that's it. So if it's already running, right? Well, it's not going to run now because we deleted. See, if I were to ask a question now, who is Descartes? Because I deleted the vector stores. Remember, it's a index not found. Yeah, that's good. And it's trying to do this. I'm not sure why. I'll have to look into it. Wait. So let's delete these and start from scratch. So when we start from scratch, and I'll put a check mark here and run it in debug mode, I'm going to do either F5 or run in debug, select Python. So we'll see what's happening, like line by line. So we're running the debug mode, waiting for imports to be loaded. Oh, yeah, and we are here. So we've just entered the for loop. Resetting docs to none. When you run in debug mode, like you have all sorts of information available to you. You can actually come over variables and see, we just set the doc to none. And when I go over doc, it says none. Anyway, we check if this file name exists because we're checking every file name in this directory, and doc directory is docs. We're setting it here. See, it doesn't exist because we don't file name, because iterate over text files in the directory. We are going to, but it doesn't exist in the it doesn't, the index doesn't exist, so we have to create it. The first one is PDF, so we're gonna do with PyPDF, load it. See, right here, attention is all you need. File name is attention is all you need. That's why it switched to the PDF. Next, we're loading and splitting page by page. And doc is not none now, so now we are embedding it. See, using embedded with persistence. Persisted, save it. So we have saved it to disk. And we append it to retrievers. We append its name. See, the name of the retriever is attention is all you need. Description. And you can see the description is good for answering questions about, it says ... but that paper, AI paper, which is the name of the file. So we're dynamically getting the names and doing all that. So if I skip this and run it, it's going to do it for Isaac Newton, René Descartes, Richard Feynman. And then now we can ask a question. For example, what is Newton famous for? Then it enters the multi-retrieval chain and picks the Isaac Newton index and says Newton is famous for formulating the laws of motion, universal gravitation. And it answers you. So this is a router, right? So you ask it a question and you have a bunch of indexes and it decides based on the description, which we are creating the description dynamically, but by no means you can enter whatever description is you like. This just does it just by file name. And picks that, retrieves the chunks from that index, in this case Isaac Newton, puts it into the query to large language model. In this case, unfortunately, it's OpenAI, so we are using Text DaVinci 003. I tried to make it work with chat, but it just takes, I'm sure it can work, but it's fine, it answers. And then the response is printed here. So you are giving it context, right? This is a bit different because it routes. So, I mean, it picks which one to use. So I thought for fun, I hope this is clear, and I hope you find this useful. This is it. It's actually quick code. The rest of the code is for Streamlit. The reason is, see, what happens is, look, when we run this, we are showing this Isaac Newton part, but there's nothing that specifies where is this coming from. Like, it's unknown. You can actually go into these Langchain classes and functions by control clicking on them. If you control click, they'll open. You can try to see what's happening, try to modify it. But what I did was, if you look here, if you're going to create a Streamlit interface out of this, you can't build it with this. Okay, chain.run is an automated process, like, so it just prints stuff into the terminal. You need to be able to separate it, because if I build a Streamlit interface, I want people to see that we have chosen the Isaac Newton index, for example. And there's no way to decipher that out of this print statement or from the chain.run statement. So therefore, turns out if you use IO library, which is included Python library and context lib, you can actually separate what is being printed in the terminal, and the output and the response are two different things. The response is whatever the model returns, and the output includes this Isaac Newton thing. And what we're doing is we're using the regex to actually find that query thing. See, whatever line has that, and then we're extracting that. And when you run it like that, so now we have access to this plus the response, so that now if we wanted to build a Streamlit interface, we can actually display to the user, okay, now you are using the Isaac Newton index. So this is solely for Streamlit purposes, which I still have to work on, but I just want to mention that. Then DuckDB. DuckDB is just something that ChromaDB uses. Yeah, it just says DuckDB, but we are using ChromaDB. See, Chroma from documents, but Chroma somehow uses something called DuckDB. What do you mean when you say where is it coming from? If you mean the information is coming from the index. So when we ask the question, Let me ask it again, because terminal erases it sometimes. Like, who is, what did Feynman do? Or let's say, what did Descartes say? I don't know. This question goes to the chain. Chain, I believe, rewrites this question. In this case, it decided to write it the same way. It also tries to reformulate the question, I believe, because I've seen instances where the question changes. Then this question is used to query. Then this question is used to pick a index from the description, good for answering questions about, say, Richard Feynman. So it goes to the LLM. LLM decides, okay, this question belongs to this index. Then this question is queried against that index, and some chunks of 500 character chunks, I believe default is 4. So 4 500 chunk most relevant information from this, what did we ask? Descartes document is returned, and it is used as content and sent back to the large language model, TextDaVinci 003, saying that this is your content, this is what the user is asking, what did René Descartes say, and then we get the answer. Descartes famously said, cogito ergo sum, I think therefore I am. In French, je pense donc je suis. So it's a lot going on in the background. How am I getting the info about Isaac Newton? Because we have the Wikipedia. I've just, this is literally what I've done. Okay, look, let me show you. New window. I did this. Isaac Newton, Wikipedia. I go to Isaac Newton's Wikipedia article. I just copied a bunch of this, not all of it. I copied a bunch of this. I copied it, Control C. Then I came to and I made a new file, and I said Isaac Newton, and I pasted it. Okay, so as you can see, it's not complete. Okay, this was my text file. Then I am converting it into a ChromaDB vector store. So I can query, I can do similarity search over it. But I'm not doing it but I'm not only converting Isaac Newton. I did the same thing for René Descartes. I did the same thing for Richard Feynman, and I downloaded Attention is All You Need. I wanted all of these to be turned into separate vector stores, and as you see, they have. See, this is the vector store for Attention is All You Need. Chroma, see, index. This is the one for Richard Feynman. This is the one for René Descartes and Isaac Newton. So when we ask the question, what the router does is it determines, well, which index is this question appropriate to. So when I ask, what did Descartes say? Right, I did ask, what did Descartes say right here? It decided to use the René Descartes index. So this is the name of the index. And the question to that index is this. So it's doing similarity search against that index. So that's how a router works. We can stop this. Here's another way. Langchain also have a prompt router, multi-prompt chain, for example. We have here 1, 2, 3, 4, 6 different prompt templates. One is for physics. It says you're a very smart physics professor. You're great at answering questions about physics. And it takes in a question. Math template is the same way. You're a very good mathematician. Biology, you're a skilled biology professor. English, you're a skilled English professor. You're great at explaining complex literary concepts. CS template is a computer scientist, and Python is a Python programmer. Now you have to give it description. This is the description guides the large language model to say, okay, physics is good for answering questions about physics. Math is good for answering. You can be as elaborate as you wish to be with these descriptions, but simple ones work fine as well. So in this case, if you were to run this, see what happens is you just define a bunch of templates, and then you define a bunch of descriptions, and then you just run the chain just to ask a question. So if you run this, and if I ask a question like, what is a telomere, which is something about DNA, it's at the both ends of the DNA to kind of keep it preserved, kind of like those things you have on your shoelaces, like the plastic thing that just keeps it from unraveling. That's what a telomere is. So when we ask this question, we enter the multi-prompt chain, and the routing decides, well, which prompt are we going to use? Do you want to use a computer science prompt for this? Well, we'll see. No, it picks the biology. Answers, a telomere is a region of the repetitive nucleotide sequence at each end of the chromosome which protects the end of the chromosome from deterioration. Like the plastic in your shoelaces protected from unraveling. Something like that. But it did choose the biology, see, from that. So it knew that. It chose biology prompt. If we were to ask, what is the difference between pip and npm? So pip is a package manager for Python. npm is a package manager for JavaScript. It decides which prompt. If you believe, or if you feel that prompting helps you, see, it chose computer science. So the difference between pip and npm is that pip is a package manager for Python, npm is a package manager for JavaScript. But it chose the CS prompt, which was, you're a proficient computer scientist, you can explain complex algorithms, data structures in simple terms. So normally, when you're trying to make a call to GPT 3.5 Turbo or GPT-4, you ahead of time you're thinking, you're trying to say, well, I want you to pretend to be this or that, like you're trying to prime it for something, right? In this case, these are all the same, but this system allows you to select it automatically, like a router. Well, I mean, not really. I mean, you still have to write the descriptions, or you let GPT-4 write it for you. It just helps a little bit. I mean, I don't know how helpful. It's better than just asking the question straight away, right? You kind of prime it. You're a skilled Python programmer, so it doesn't talk about JavaScript, for example, things like that. Like physics, if you were to ask, what is Big Bang? We're hoping it's going to pick physics template. See, physics. Big Bang is a scientific thing. So now we're talking about two things. So there's the multi-prompt router, which allows you to select from all kinds of different prompts. And then there's the multi retrieval QA chain, which allows you to select from multiple different indexes, vector store indexes. It's probably a way to kind of bring them together. I don't know. It requires some thought, but I mean, it works. The original implementation, where was it? I think if you go back, one second. Oh no, I closed it. Oh no, here. Wait. Oh yeah, here. So you can also see this. It's cute. They also included personal text, but you just load documents, and then you create some list of information about them, and then that's it. You just give it to the retrieval QA chain, and it does it. I just made it so that all of this stuff is happening programmatically within this for loop. So that being said, let's test this. The question that came to my mind, prompts trying to use them with an agent. No, you should continue doing that, Dane. But I'm saying, if if you're building an app, like let's say you're building, I don't know, some kind of tutoring app, which is going to tutor people in programming, and it's going to tutor people in Python plus JavaScript plus something else. You can still you are free to write your prompt like from scratch, but you can allow the system to choose its own prompt this way. That's what routing is. So if you feel like you're building a thing which requires many different types of prompts, and it is difficult for you to determine which prompt is going to be used for what question, then this is what this is made for, essentially. If I were able to explain it. But the question that comes into mind is, here we have 6 or 7 templates, and here we have a total of 4 files. What if I had 10 files, 20 files? Would it still work? Essentially, it's just going off of the description. What if I had 50 prompts? Would it still be able to choose, So I thought, I've never tried this, so I don't have an answer for it, but I thought we'll maybe try to work with, see if we can, let's test it, is what I'm saying. So with the prompt router, you not only need the prompt, which is the dynamic prompt, which takes an input, right? That is the user query, like ask a question. Whatever you put here goes into the input. Plus the descriptions. So let's copy all of these as an example to GPT-4. Let me find it real quick. It's kind of here. Let's keep that as, okay, so we just put this as information. And I made this other video with the OmniSolver video, the Camel Autonomous Co-op Agents, I believe. Yeah, this one had roles. See, so I have all these roles. There's a total of 50 of them. So I'm just going to copy this and say, create templates and infos. I'm going to say create templates and infos for all the following, which is all the stuff. Let's see what it does. Good. So it's going to write, so we're going to have a whole bunch of stuff to try out, like just to test out if it will get confused. Like, it's one thing to have 6 different prompts, but what if you have a whole lot? Oh no, it didn't want to write. It's a stop generating. Maybe we should have used 3.5 turbo for this, right? Let's just, we're not going to wait for all 50 of them to be written, but if you have 10 or more, that's going to, all right, I'm going to copy this. GPT 3.5 should be able to do this. It's not returning. So I just want to say respond in markdown code block. Let's make it easier. You can say include all response in markdown. Okay, good. Oh, I don't want it to it's doing it, but I'll have to copy all of these one by one. Okay, accountant, let's just do this. What's the problem? Template, Python template. You know what? I'm gonna let Copilot do this. Accountant or template. There we go. Lawyer template. All right. Doctor template. Teacher template. Let's just get some of these. The only reason engineer template. I'm using GitHub Copilot to do this, obviously. Dentist. Nurse. Psychologist. So like you definitely don't want to rely on it as for psychology, dentistry, engineering. I mean, I just want to say that. But here we're testing it. Scientist template. Let's get one more. Economist. Architect. Okay, well this will be it. All right. Why is it giving an error? Let me figure this out. Oh, they all begin. Oh, I see. Oh, I made a mistake. They all have to end like that. Fine. So now we have a lot of templates. The idea is that really get confused. Right now, we also need the descriptions. Oh my God. We don't need that. Accountant, lawyer, was it doctor? Yep. Teacher, engineer, dentist, nurse, psychologist, scientist, architect was the last one. So now we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 17 of them. Let's now run this. So this is just to see if it'll get confused. Let's pick something about architecture. What is Baroque? Baroque. Let's see. It's magic. Look, it picked English, which is fine, I guess, because Baroque can be interpreted as English. Baroque is a period of European art and architecture, because this deals with literature. Fine. That's an honest mistake. What is Baroque? If I can write it, Baroque structure. Because Baroque is some kind of like style. I don't even know what it looks like, but let's see if it picks. We wanted to pick architect. See, it did pick architect. Good. What else do we have? We have an engineer. How are bridges built? This might seem obvious, but you let a large language model pick out of like 17 options. It's not so obvious like when that happens. It picked the engineer. You don't have to read the answer, but okay. Teacher. What is pedagogy? I think it's something about teaching. because define pedagogy is method and practice of teaching, especially in academic subjects. So this should trigger teacher, and it did. See, it triggered teacher. So this is pretty awesome. Accountant, how to save money. It's pretty vague, pretty open. Economist. Pick economist. I was hoping for, but that's fine. Accountant, economist. Who's Guess I. Do you want to get your advice for how to save money from an economist or from an accountant? You choose. Anyway, this I'm actually surprised. I never did this before. So we gave it 17 different options, and it was able to choose pretty all right. What do you think? So that's for the prompt. So we can do the same with the files. Like this is prompts are one thing, but to pick a whole entire vector store, like to do a thing, is a whole nother. So what I'm going to do is just pick a bunch of Wikipedia articles and just save them here. I'm going to go to Wikipedia. There's a random article here. I think right here, random article. Oh, well, we want something. Let's not do random. Let's do okay, let's go with scientists. All right. John von Neumann, Wikipedia. I'm just gonna pick some, and here you come back, make a new file in the docs. John von Neumann. This gentleman was one of the founding fathers of computation, computers. John von Neumann. Maybe there's some. Okay, let's see, relativity wiki, like something about theory of relativity. Let's copy this. Not all of it. I just want something. Go with it. Relativity, theory of relativity. .txt. You can have PDF documents too, but we would have to download them, and PDF documents usually are long, and they take a while to embed and split. So that's why I'm just doing this real quick. It's a Big Bang. New file, Big Bang.txt. We can do more. 1, 2. So we have 1, 2, 3, 4, 5, 6, 7. It's completed 10 real quick. Give me ideas if you like. Another one. Let's do Coppergar. Let's do Coppercar's constant. Why not? This is an interesting thing. Oh, there's not much information. Let's do Ramanujan. He's an Indian mathematician. Ramanujan. Cool guy. There's a movie about that, about him. What is his name, though? Let's get his name right. Srinivasa Ramanujan. Let's make sure Big Bang is correct. Because this is a real problem, you know, with this, if you give it this many text, you know, here, we're just going to do 2 more. Sorry, I just wanted to show this to you on screen. I mean, also, sometimes you have to do this manual work. let's do one more then. Let's do something completely like some actor or something, or singer. Let's do Beyonce. Beyonce Wikipedia. So it doesn't have to be all scientists, right? All the time. All right, so now we have these. Let's delete these just to show you again that we are creating these on the fly. So you have one PDF. You can have as many PDFs as possible. I mean, you like. It just takes a long time to deal with PDFs. And then now we're gonna run this again. Oh, get out of it. Run it. So we're going to create a vector store out of all of these. 1, 2, 3, 4, 5, 6, 9. 9 documents. See? Potentials all you need: Beyonce, Big Bang, Isaac Newton, John von Neumann, René Descartes, Richard Feynman, Srinivasa Ramanujan, theory of relativity. What would you like to know? So, let's say, what if you were there, like, so we have Beyonce is kind of like out of the, like, it's different, right? So let's say, what is her best song? Let's just say. So this is obviously interesting. It's very nondescript. It picked Beyonce. Look, from this question and out of these 9, it picked Beyonce, and it says, "I'm sorry, I don't know." Because the Wikipedia article the part of the Wikipedia article probably doesn't contain that, but then we can say who was the founding father of computing. I made a typo, but it picked John von Neumann. Well, this is pretty remarkable, actually, and it did say John von Neumann, but it did pick that index. That's the interesting part. Could you add a tool to search Wikipedia? Yeah, you can, actually. But the idea is that you already have the vector store. You can also add Wikipedia. You can, for example, take a look at the question, and then you can make a call to GPT to say that, well, what Wikipedia article this question would be most interesting in. Then it would probably return computing. Then you could retrieve the computing article. And then you could also embed that. I mean, I was also thinking of stuff like, I mean, the world is your oyster if you want to go that route. Yes, you can. I mean, but these are already informational indexes, so we are already querying over these, right? So who did think a lot about infinity? And I'll give you a hint. It was Srinivasa Ramanujan. So this is a really vague question, honestly, because it could also be Richard Feynman. Let's say it should pick Ramanujan, but yeah, it picked Ramanujan. So I'm really surprised. This is the first time I'm doing this. This is quite a lot of documents. You know, there's 9 documents, and it's picking out of really like just about a question about infinity. Yeah, so I guess you can have, I don't know how it would perform with 100 indexes, but it does really well with 9. We can add more if you're not bored about it, but I mean, I don't know what difference it's going to make. At some point, it has to break down. I'm not sure when. Another thing is, so I mean, I'm kind of done talking about this. Like I said, the code is available at Patreon. Link is in the description. Feel free to build on it. I like the fact that this builds dynamically. Also, there is the multi-prompt thing you can use. They're both in the Patreon. Just want to mention, I'm sure you already know, but I did build a website, echohive.live. You can search my videos. I have to update this with my latest videos, but for example, Dane, you were asking about LLM chain. See, if you were to type it here, I guess that's not return the chain. LLM chain should return, I thought. Oh yeah, okay, because they all have chain in it. So these are like the videos that is related to chains. Well, I mean, search for Langchain. Langchain have all the chains in it. But let's say agents. You can find the videos, watch them. These are the videos I created. Anyway, it's echohive.live. If you want to check out, I created over 130 plus videos. So go download links are there too. So when you click, it'll take you to Patreon. For that, you can watch the video, look at the description for different videos. So anybody have any questions on this? Otherwise, I'll just talk about autocoder a little bit, and then probably we'll end this live stream. What did I have here? Content. This we talked about. Sorry. Oh yeah. Okay. So I had another multi-PDF. So I sometimes don't even know how to name. Like I'm gonna make a video on this, and I don't even know how to name it because this code. Sorry, this one. No. So this multi-file PDF essentially deals with multi-files, including PDFs, but you can only query, talk with one. I do want to see autocode. Okay, we'll go there quickly, but you can only query one document at a time. As a matter of fact, I didn't want to do that. I was wondering if this multi-retrieval QA chain could do multiples, and you can actually go to the class. I even asked GPT-4 too. There is really no easy way to like pick, like for example, it would be interesting to talk about Big Bang and the theory of relativity at the same time, to query both, but there's no real easy way, so I kind of gave up on that idea. But I did also before build the multi-PDF one where it does exactly the same thing, but only with PDF files. You can actually combine PDF files. You can choose. See, if you run it, just want to show you. It asks you which one you want to talk to. See, it lists you, okay, this is what we have. Of course, it's going off by PDFs. It says we have NVIDIA 2002 annual report, Old Man and the Sea. And we have a combined document, which was NVIDIA and the Old Man and the Sea. So this one actually allows you to combine documents. See, it says select the indexes to query separated by commas. If you had more, so we only had 2 here. If you had more, you can actually say 1 and 5. So it will combine whatever the 1 and 5 is, so you can talk to that. So this is a different one, which was this one. Let me show you real quick. This one, how to talk to multiple PDFs, Langchain. Anyway, so the autocoder thing is let me close this. Content, yeah. No, not this. I thought I had it open. Oh yeah, here. Yeah, so the last video, I don't know if you watched the last video, but this one. The GPT-4 autocoder 2. What I try to do is, okay, well, you do need some, if you were to try to build something with GPT-4 even, about Langchain, it's just not going to know. It's if you go to Langchain OpenAI and try to ask anything about what is Langchain library for Python, and that is GPT-4, it just doesn't know. So it's not going to be able to write you any Langchain code. Just not going to. It'll try to. It'll pretend to, and it's not going to be right. And this is going to be the same for a whole lot of new libraries. Like it's not going to know what AutoGPT is, for example. It's not going to know what Baby AGI is. It's not going to know what Steamship is, right? So then the idea was, well, we can give it context. You know, you can give it context. I can just copy paste stuff right here, right? I can just simply copy paste stuff. So that's essentially the most basic form of giving context is copy paste. And it works. I know that it works. I've been doing it last few months. But what about, I thought, what if we could put in direct URLs? Like, let's say you're at Langchain documentation and you want to use some memory type, but you want to combine it with some chain, and maybe you want to use entity memory, which is probably not very stable. But here's the documentation with a bunch of outputs and stuff, and normally you would have to just sift through this yourself, copy paste into your favorite ID and to figure it out, or combine these and ask GPT to kind of help you with that. But my idea was that why don't we actually copy these URLs, which then gets all the information. Let's get all the information out of it. Not only that, that's what Playwright does. So you extract the information, but then let's send it to GPT-4 for extracting all the relevant code, because these imports are useful. You want to know these imports. You definitely want to know how this code works and what it accepts, but you don't care for this sample response, for example. So if you were to copy paste all of these things, then you're going to be eating up your context limit. You're going to be eating into your tokens and whatnot, right? But anyway, so I did this, but then we did a live stream, and it has mixed results. It works. It works really well, probably for simple URLs, but the more complex you turn it into, then you start running into problems. So then I've been working with a different thing. Not this. 1 second. And another problem with this approach was that so we're just going to talk quickly about this, but the browse one uses Langchain. See, we are using here the Langchain agent executor from agents and tools. And when this runs, it returns the last line of the error message, and that sometimes is not very descriptive for a model to really work with. And the reason for that is if you go to the imports, and there's this huge prompt that I wrote for it, it is instructed to try to solve its problems by using print statements. Right here, you'll see, use print statements where necessary, because that's what I would do. I mean, it doesn't have access to a debugger like I would in Visual Studio Code, so you would use print statements to see like what's happening. And but then it doesn't see that, essentially. So it tries. So it understands the prompt and it tries to use print statements, but then the print statements values are not going back into it, because the Langchain only gets the error message. So I did after some tinkering, I realized, if I can find, the right, sorry. Oh, Why is it here? Anyway, they got mixed up. Why did that happen? Anyway, it doesn't matter. So what I realized is here, check this out. So if I said, okay, fine. You know what? I'm gonna run the code myself, which you can do with sub process. So you don't necessarily need Langchain. Langchain actually uses sub process anyway. So what you do is, I said, forget about URLs. I'm just gonna take the time to collect the content myself. Okay, and I don't mind doing that. And honestly, the original approach of giving URL, like you send the whole URL to GPT-4 to sift through the code files and return it to you, that takes a whole minute anyway. Like you probably can copy paste the code from Langchain documentation in less time than that, plus no money. Like, and that's also going to cost you like 10 to 20 cents with GPT-4. Like you just copy these, like you find the things that you're interested in. I thought this is what I do anyway. So if I want entity memory, well, here is all the code for entity memory. I have to study this anyway. Like I have to work with this. There's no other, I have to find code examples to work with this anyway. So here is the code example. So I said, don't be lazy because it just doesn't work perfectly. I said, well, I will do this myself. I will copy these and I do. So you just copy the relevant code as example for content, for context, which you're going to give to GPT, right? And put it into content.py, for example, here. For example, here is the sample code for conversational buffer memory. Here is the code for recursive character text splitter, which is useful. So I'm just giving it generic. Do I want to split text? Yes. And this is the code from Langchain. This is the code for conversational buffer memory. This is the general implementation for ChromaDB vector store. This is how we implement it, generally speaking. Example code for implementing router chains. See, this is actually how I got this other code working. I mean, router chains for vector and its files, right? The funny thing is that if you have this content, even though the router chain here uses files, you can actually say, well, okay, implement this, but with Chroma, and it will be able to do that because now you're giving it, because it understands, because here it says, all right, well, this imported files and doing files from document, but how far is it from saying importing Chroma from document? Like, you know, it'll be able to like solve those simple problems. So I thought this is a useful approach. Number one, this is not fully automated, but I'll just tell you, I mean, I don't think there's any fully automated system that just does it, and it ends up wasting a lot of time and a lot of token money that you're going to be wasting. I mean, the hope is that it will be fully automated, but until like GPT-5 comes along or something like that, I think what you ought to do, in my opinion, this is what I've decided to do, is like spend some time and collect the code that is necessary for what you want to do. Like there is no fine tuning here. Like this is just copy paste, because this one is files, this one is ChromaDB, but this is good enough. I tell you that, and this is better than any automated thing is gonna put together. The URL one that I mentioned, the one I did, works fine, but I did experiments with it. If the URL is too long, it's just not gonna do it. Like this would probably be all right. I mean, this is probably too long, and most of the longness is because of this like sample responses. You don't really need these. You need the code. And yeah. Anyway, I hope I'm being clear here. Once you do that, now you have your content, and then all you have to do is then take that content, because it's hand selected content. You've already done the work, and after that, just what I'm experimenting with is running recursive calls to GPT, like with instructions. Instructions are received, obviously, if I run this, you'll see. Content is automatically drawn from content. There's no URL, whatnot. I could incorporate that back in, but so it already has the content, and I'm saying enter user instructions. I can write anything here. This is multi-line input, so I can write multi-line, and then I'll have to say done. And then iteration 1 begins, so it is using GPT-4 this turn. So the cool thing is here, I can specify with when GPT-4. So another thing is that GPT 3.5 Turbo is not going to do very well, but it's going to do all right. GPT-4 is going to do the best, but GPT-4 is going to be slow and expensive. So the idea is to set when to use GPT-4. Let me actually break out of this. I didn't even give it real instructions. We do have to wait until GPT-4 is done, and then it's going to break. But if I were to say 5 here, what this code is going to do, I'm still working on this code, is that same. It's going to get into request correction function. And one sec. So it's gonna check whatever the iteration is. Iteration starts at 1. We give it at the bottom here. Anyway, so it starts at 1, and it's gonna use the content and the user instructions with GPT 3.5 Turbo, let's say 4 times, and on the 5th one, it's going to use GPT-4. Well, it's going to be like this. And it's going to start with GPT 3.5, try 4 times. This is a check for if the code doesn't return any errors, then we're good. If not, then we're going to consult the GPT-4. So instead of using either one way or the other, we're like doing, okay, let GPT 3.5 try for a while. If it fails, maybe go to GPT-4. Then after that, actually, I implemented this so that it takes user interaction. So when we hit this, we not only switch to GPT-4, so it tries with GPT 3.5 4 times. And on the 5th one, it tries with GPT-4. And after that, it's ask for user input. Yeah, see? So we do the same check. So, I mean, this is all customizable. It says provide additional instructions. Because this process can get stuck in a loop. Sometimes it keeps getting the same error and trying to do the exact same thing again and again. So this gives an ability to use different models to try to solve the problem, plus user instructions. Because if you're hands-on and you're watching what the error messages are, maybe you can give it some hints, like don't do that, like use this, for example, or copy paste something that you know will work. Like, so help it, right? Don't auto everything. Like, be there to help it, guide it. So it's already doing a lot of the heavy lifting. But so that brings me to when you run, turns out when you run sub-process, you can do all sorts of interesting things. It turns out what is printed in the terminal is separated into multiple components, like std out is whatever, for example, whenever you're trying to print something, I believe that is under the category of std out. And std error, this err, see this result. So what we're doing is subprocess.run whatever, and then we return result. So this result is something like a dictionary, and it has multiple elements in it. std out is what normally would print under normal circumstances into the terminal, versus std error is what whenever it returns an error. And then I was thinking, oh, cool, but so then if we decide to like maybe print something, that would be included in the std out and then std err. So if you can split those things, you can decide to do whatever you want with them. You can, meaning, if you look at the prompt, you can put it in, right? This is like the subsequent iterations prompt. So we are putting both the content, which we have handpicked, plus user instructions, plus whatever code was generated previously, plus the regularly what we would print, plus the error message, right? Yeah. So does this work perfectly? No, it doesn't. I'm working on it, but this is what I wanted to say. When it works well enough, I'll make a video about it. So that's where I'm at right now. But anyway, I kind of ran out of things to say. But okay, but they did say, so I'm calling this autocoder 3. Roughly, this is how it works. Let's run this then at least one time. So this has all the content. So you got to ask something specific to the content. See, we do have the splitter here. We do have chroma, how to create chroma indexes, and we do have the router, which is the multi-retrieval QA chain. So I'm just gonna, let's keep it simple. Well, hopefully. Let me first correct some of the code. Here, I just want to remove that, and let's do this 3 times. So after 3 times, we are asked user input and GPT-4. This should work. So run this. What we're going to ask is create a multi-retrieval QA chain with ChromaDB instead of files. Now we say done. And we enter iteration 1. We're going to use, I believe, 2 or 3 times GPT 3.5. Anyway, you'll see. We're going to have to wait. It's going to save its responses to response.py. Yeah, I think that, when you start thinking about these things, there's a whole, say error, we're receiving error messages. So iteration 1, we use GPT 3.5, which returned this response.py. It automatically writes it to this file, and it is using ChromaDB. It already did it, like so. But std out returned nothing, but std error is that no such file or directory, because we do not have state-of-the-union.txt. We just don't. So this is just this is our mistake. I mean, we should have specified which file we were going for. But I just want to say it did create the ChromaDB. So it changed the file. So it's going to keep running into the exact same error. But see, iteration 3, it's switching to GPT-4. After GPT-4 kind of takes a look at it, we're going to get a chance to make a user input. Let's go with that, and we'll try to correct our mistake with that input. Now, but this is because it's trying to load some text files, and it's going with whatever the content was loading. And it just doesn't know. It has no understanding of what we have in our working directory, so it cannot check any of those. You could make it check it. So this is going to be obviously slow. But I thought this was pretty cool to switch back and forth. And you can have, you can have as much, you can have the entire traceback fed back into the model when you're doing it like yourself. Anyway, this is the response. This is the code that, that you have quite a lot of control, essentially. Oh, I don't know if you heard that little beep. I'll talk about that too. So We again got the same error, so GPT-4 couldn't figure it out either. Now we can provide some feedback. But before doing that, I just want to say, while I was running this, I was also watching some TV because I didn't want to sit in front of my computer like 20 minutes at a time if I'm running it for 10 times. You can actually use this WinSound library, which is in Python, to make sounds for you. If you're running loops, you can use the WinSound to make a sound for you to alert you. Okay, it's like, it only does this when user input is required. So, you can go and watch TV and come back and like review what had happened and then enter your input. So here I'm going to say, instead of the txt files you are using, use Rene Descartes.txt in docs folder. This should fix the error. See, now we're putting inputs. This is multi-line input, so we have to say done after. So now we're moving on to iteration 4 with 3.5. Let's see if this helps. Can I place the error with code base to allow it to content to fix? Yeah, you can. I mean, why would, I don't understand when you say place the error with code base. It already, I mean, it already knows what it had responded with, like this whole code it wrote, plus it includes the error. But I mean, yeah, I mean, your imagination is the limit, really. What happened? No such file or directory, because it's using this deep. So it should get rid of those. If it were to get rid of these dot slashes, then it would work. Let's see if it'll figure it out. Yeah, see, it's making a mistake. So another thing we can do is I'm just, as I was running this, you start getting ideas. Because it is writing its output into a file, response.py, we can modify this file. And because we are giving it a chance to pause and ask us input every 3 iterations, which is coming up, we can actually modify this file directly. And the next time we let it run, it will run with the modified file. So you not only are able to give it content, like with this implementation, you're not only able to give it content, plus instructions every once in a while, plus the ability to switch models from 3.5 to GPT-4, you can actually directly modify the output file. Why not? We all want everything to be fully automated, I know, but I think until full automation is possible, we have to do these things to save time. And if you want running and working code, this is already pretty impressive stuff that's happening. Then we are doing that. We are giving the code plus the error. Look, see. Look at the prompt. See, you are provided the code content. We are providing our original handpicked content. Then we let it create code, which is the response.py, and we are including it here in previous code. We are also including user input. We are also including the error message. So we are doing that. Yeah. Okay, so now it's asking for our user input again. So I'm saying, oh look, it actually moved on to a different error. Let's see what response.py looks like. Like, see, as you see, it actually was able to fix that. Remember, it was having that ... error. If we go back, Yeah, the term, I see, it was able to remove this dot slashes, but then now it's having Unicode decode error in line 14, which is right here. So when it's trying to read this Rene Descartes.txt file, it's having a Unicode error, which is the most annoying, most common error that's just gonna happen all the time. All you have to do is encode it with UTF and ignore errors. So we're gonna say, because I've dealt with this solution, you can, because I know it, I would say encode. So I would say, because I know it, I would say when you open the file, use UTF-8 encoding and ignore errors, because you can do that. But this is if you know, right? But you wouldn't, if you're new, you wouldn't know this. So if you're getting Unicode error, what you can do is, like, I mean, if I was new, like I'm just like for the first time witnessing this, handle all right errors. Like, you know, I mean, what else would you know? What's the use case you're working here? It's an autocoder, trying to autocode. We started this live stream with the talking about the Langchain routers. Where was it? I think. Yeah, we were talking about the router chains, but then we talked enough about it, Jack Martin. Then we moved on to autocoder. Yeah, and autocoder tries to write code automatically. Oh yeah, see, just pay attention with multi-line inputs. You just press enter and you think you have submitted it, but you haven't. You do have to say done. Yeah, so we're entering iteration 7. What's blocking us is this Unicode error, which is happening right here. This has to do something with a character here not being, probably something, this one. You see that? I don't know. So there are characters here, some French characters or whatever, that is not recognized. It's throwing Unicode error. You can handle those, but this doesn't handle it. This has to say encoding UTF-8. If it said that, it would handle it. And then you can also say ignore somewhere here. Ignore errors or something. I forgot. But we're not going to write it. We're going to try to get GPT to write it. And look, it fixed that. Actually, oh shit. While I was messing with it, it actually wrote it. It actually moved on from that error, so it must have fixed it. Now it's having a string object has no attribute page content. This is common. It's happening right here. Opens it. Docs. Oh, again, it had GPT-4 is going to try. Let's see what it does. So when you're trying to autocode some Langchain stuff, this comes up a lot. Not the Unicode. That's easy to handle, but this string object has no attribute page content is happening at line 36. Not exact, because the code had changed since then. It's just that when you, what is it doing? Okay, it's reading Descartes. Okay, it's probably happening here. Because Descartes is just a string. personal text is a list. So it's turning it into a list. I think this is fine. I'm not sure. I'm confused myself right now. But here it says line 29. Yeah, it's happening somewhere here. Because the docs that ChromaDB needs to accept, I believe, has to be text. So because it saves it to a file, we can actually run this ourselves. I'm not sure if we're going to succeed. Oh, override. So the output of each time the output of GPT is written into response.py. I have to break out of this and run it. Yeah, we're getting Unicode error. Let's do encoding UTF-8. Right here, line 28. See, this docs needs to take in, I think, some string, and I believe so. If we were to get rid of this, because Descartes is string, I know that. If we run this again, no, we're still getting that error. It has no attribute page content because it is a string. Anyway, not 100%. No, definitely not. It's not. And the way, because we see, the thing is, we're loading it with open and it's just loading text. Okay, so Descartes is just text, personal text is a list. But if you look at the content, the way you load is with a text loader. The text loader loads in splits, and it's actually a list of what's called a document object. Maybe there's an example here. So it's just a matter of like finding there's really nothing magical happening. It's just you have to find the text content out of an object. Like if you ever dealt with like a JSON object, or it's the way the Langchain loads documents. Let me show you with the multi-file. Especially with the PDF. I'm gonna put a mark here. I'm gonna have to delete these. And after this, we'll end the stream. Oh, sure. Right. Docs. We'll have to grab the doc again. 1 second. Okay, so I'm just going to put this single PDF here. And I'm going to put a break here and run this with debug. And we're going to see what's happening real quick. So we come here and stop. So the PyPDF loader is going to try to load this document. But the same thing will happen if you're using like a text loader, like any kind of Langchain loader does this. It's going to do it. And also the splitters. This is just our loader, but when we load and split, see this, pay attention to this doc. is a list of, see, let's look here. Doc, where's doc? See, this document object is this list made up of this document object, which is made up of a tuple. Okay, so you have to like enter that, and that has what's called a page content thing. See, and the first one, so the doc is made up of all these list of document objects, which is a page content element in it, which has the text inside. So unless you have to kind of access this text, the way you do it is you would say like print doc's like first element. If you were to say the first element, now we are at 0, 0. Okay, so now we've found this document object. Then we would have to say page content. If we were to do this, now we are accessing the text element in it. See, and it's I hope this is just how Langchain thought of kind of doing like kind of combining documents, splitting documents. GPT has no idea that it is this way, and it tries to access this. Like it says a lot of times it'll try to do this like text. It'll do this. It's gonna fail. And then it tries to do content, and it throws an error because it's not content, it's not text, it's not content, it is page content. It just doesn't know that. The only way you can know is if it prints it, because the only way I can know it is if I print doc. Let's run this again. Yeah, we didn't index it, so. Oh, not like this. Well, how come all of it came back? Run it with F5. With debugging, you'll see what's happening here. The reason I was trying to prompt it to do print statements is because that's how humans, like that's how programmers understand. Okay, we're loading, all right, and then we have our doc. But if you're not debugging, we don't have access to any of these. Our only option is to print it. So we're going to print it right after this loads and splits. And when you print it, here we have printed it, and then you can go back and see, oh, look, it's a list. You can see it with the square brackets. Let me zoom in. It's a list, which is a document object, which has a page underscore content, which has all the information you need. That's how I would figure this out, and that's how GPT can figure it out, but it has to be able to print it. If it prints it, it understands, actually. But to be able to feed the result of its printing is you have to feed it back. And this is not an error message. That's why I was talking about like the std out would hopefully. So there's a lot of moving parts. You have to get GPT to use a print statement at the right time, printed, get this, feed it back to itself that it can say, oh, I have to reach the first element of a list which has page content item in it. If it can see this, it will be able to reach this, then won't get that error that we were running into. String object has no element called page underscore content. Anyway, I hope this was helpful. I'm tired, and see you in the next one. Take care. Thank you for watching.